Hi, this is Eric Thomas in the ODOT Office of Production, and in this video I'm going to take a look at another Visual Basic application I wrote. This one is used to take a set of cross-section sheets that have been processed into one model and to split these out into separate design files for digital submission. So what I have is just a group of cross-section sheets that I ran with GeoPack, and I'm going to start by looking at a couple of the GeoPack settings that I used when I processed these sheets. So I'll open my run. And in my run under the sheet DGN file options, there are three options on how to clip these sheets. The first one is all sheets in the active model, and that's the option that I used, and that's probably the option that most users prefer. Second option is one sheet per model. So the difference is this will generate multiple models, each with one sheet, as opposed to having all the sheets in just one model. Either of those options is fine for an ODOT project. It's really kind of user preference on which one you prefer to use. And again, my preference is the all sheets in the active model. I just find it easier to work with my sheets when they're all in one model. The third option is one sheet per model / display all. What that does is make multiple models, each with one sheet, and it makes one more model with every sheet referenced into that model. And we do not recommend that option for ODOT use. So I ran this with all sheets in the active model. And I'll just go ahead and close my run here. And this is what I got from that, is all these sheets just in one sheet model. So let's look at the ODOT application. So from our ODOT pull down, I'll pick Excess Utilities, and then I'll pick Excess Split Sheets. And again, this application is used to take these sheets and put them in separate design files. And this is intended to be used as the very last thing you do on your cross-section sheets before submitting the files to ODOT. ODOT CAD standards call for one sheet per file, so this will allow you to follow that easily by letting this application do the work of splitting these into multiple sheet files. You can see at the top I've got a drop-down item here with two items, and this is just for you to select which option was used when you clip the sheets. And I used the all sheets in the active model. Now it's found 12 sheets in this file, and there's a scan button. The scan button is used if I change design files to tell the application to go out and scan for sheets in the file after I've changed files. So since I just opened the application in a cross-section file, it already found 12, and then that's just a way for you to tell the application to go out and find what's out there if you have changed files since it had been opened. Now the application does assume you're following the ODOT file naming convention. So down here you can see an output file name, and it's extracted the PID number from my active design file, and it's also extracted the next file number from my active design file's name. So this is excess file number 1, and it's ready to generate excess file number 002. Now it will also look for any other excess files in the current folder, and if it had found some other ones in there, it will increment that next file number appropriately. So the thing to remember here is the next file number is not necessarily the sheet number, it's just the files of that type. So the next one would be 002. And I could change either of these values here if I needed to, but I'm going to just leave that alone and follow the standard. So I'll go ahead and tell it to process sheets. And as it's processing, what it's doing is taking my first file, copying it as 002, renaming it to 002, and then deleting all the sheets that are not needed for that file. And now you can see it's on 003, it's deleted the extra sheets, does a fit view, closes that file and moves on to 004, deletes sheets, does a fit view, and so on until it gets done processing the sheets. When the application has completed processing, you'll get a processing complete message, and it will return to the originating file. So I'm back in my excess 001 design file. And I had 12 sheets, so it generated up to 0013, and now it's ready to go with the next file would be 014. Let's go ahead and open one of those files. Just to verify that it worked properly. And I'll do a fit view here, and I can see I don't have any other sheets in the file. Now I want to make a couple of notes about some of the things the application does. If I open my Windows Explorer, you can see I have my title and my comments fields displayed, and there are no title or comments values shown here. I'm in Windows 7, and that's just a problem with Windows 7. For some reason, the Windows Explorer is not showing those title and comments values. But if I look at the file itself, under File Properties, I can see the title of cross-section State Route 185 was applied, and then the station range was applied. And what that's doing is taking my title block information and applying that as titles and comments. So each one of these sheet files does have those values assigned. And if I look at my MicroStation file open dialog, I can turn on the title here, move that over, and I can turn on the comments here. I know it's in there somewhere. There it is. And again, let me move that over. And you can see that MicroStation does display those values even though Windows doesn't. So that's kind of nice if you like to use the title and comments. Again, with Windows 7, that's an outstanding issue that we hope to be resolved in a future release. But at least in the MicroStation file open dialog, you can see those. And that makes it really nice to find the proper sheet in your cross-section design files. So that's really all there is to the application. And again, that application is intended to be used at the end of your cross-section development process when you're getting your files ready for a digital submission. If you have any questions or problem with this application, just contact the ODOT Office of Production. Thanks.